The ordinary will wait for things to happen, but those who achieve the extraordinary, they create their future. Welcome to Bisnomics, your weekend's most profitable 60 minutes. I'm Tharundu Amarasekara, and this is the show where our advantage today is intended for your advantage tomorrow. A smart workplace, a workplace with robotics, enabling digital transformation. Much has been spoken about this in many different forums. But what is the reality? How far away are we from a workplace where the robots are doing the action? Or is the future already here? Let's focus about that today in this episode of Bisnomics. And joining me for this discussion is Professor Rohan Munasinghe, an expert in the field from the University of Moratuwa. Professor, welcome to Bisnomics. Absolute pleasure to have you.
My pleasure, Tharundu.
Professor, tell me about how the robots of today, because robots have been a discussion for many decades now. But how are the modern day robots we see in the workplace, or we don't see at all, but they are there? How are they different from the original robots of the 80s and the 90s?
Yeah, robots used to be mechanical machines from 1950s, even the time they were invented. But when it comes to 80s, as you said, they were mostly doing manufacturing jobs, automation. But now it's very different. You can see robots not only in the workplaces, manufacturing industry, that is industrial robotics, but there are a lot of other different types of robots like vacuum cleaning robots, self-driving cars, drones, underwater vehicles, wheelchairs, medical robotics, doing surgeries and all that. Robots are everywhere. So therefore, the old legacy definition of robots being manufacturing tool, automated tool, it has now already changed. So it's everywhere. We call it flexible automation, automation using robotics.
Flexible automation.
Exactly.
Interesting term.
Yes. So it's not hard, just like any other machines like photocopy machines and things like that. You can program it. It's very flexible for the engineer to use it for various different applications, same machine. And also the distance between robot and the humans have shrunk to zero now. So you can work with a robot very close range, whereas if you go back to 80s and all, nobody dare to get close to a robot because it can be very fatal. So now the controls, electronics and sensors, AI, all have done their job, particularly the AI, to make sure that the robots have the right amount of intelligence to take decisions so that they are not actually causing any risk to people who are around them. So therefore, the robots today, as you asked, Tharundu, I think just like another companion, they can work with humans, they can work different places, hospitals, hotels, even households, doing various things.
Professor, are you saying that the robots of today have become more adaptive to humans and our environments? Is that what you are saying? Because you said flexible automation, and you mentioned how easily these robots can integrate into our life environment, our work environment. Are you mentioning about adaptive robotics here actually?
Exactly. Robots have the inherent capability of adapting to the situations. Already they have been deployed in various manufacturing industries. This is where the money is made, right? But other sectors like medical robotics, for example, is a very, very niche area. I don't think anybody is making a lot of money making medical robots because it's a bit too early now. But in the future, definitely it will be another very serious area. So
not making any money yet.
Yet. Every invention is like that. There is a life cycle, and after a certain time only they get to the commercial track, so that they are making their returns on their investments. So adaptability is key here. You can't have adaptability without AI, of course, and the vision systems, machine learnings, big data. So these are the buzzwords these days in engineering technical fields.
And if you could just demystify some of those words for us, Professor, like what exactly is big data? What is this AI? If you could just give us a basic explanation for the benefit of all the viewers.
Yes, big data is basically by this intrinsic meaning is combining lots and lots of data at the same time and then combine them together, just like you become the God who knows everything of the world. Now, there are technologies already being developed now to bring the entire road maps of the entire world into a small chip like this. And if you put that onto a self-driving car, it can drive anywhere in the world, something like that. So, to make that happen,
a little bit like a Google Maps, but at a much more powerful scale.
exactly, everything is in one small place. So, then you have systems on chip, you know chips, right? Everybody knows it, doing specific thing. But what about systems on chip? It's not one single thing on a chip, but entire system on a chip. So, it's like your piece of your brain. So, it's not only sensors, actuators, decision making, thinking, sensor fusion, all these things are happening concurrently in one single chip. So, therefore, you can see the robotics is not actually the core here. The core here is electronics, communication, data,
Correct.
storage, processing and all, and what you see altogether outcome as robotics, or a robot doing some fantastic job.
But there's a lot of other supportive technologies behind it.
Exactly.
Professor, let's talk about the areas of very high impact. In your understanding, as someone who does a lot of research on this field as well, in what areas of business do we see the strongest possible impact from robotics? And I'm being told that nowadays robots need not be the hardware machines we see. We can have robots in a software form inside our computers, or RPA, robotic process automation. Tell us about it.
Yeah, robotics is a $50 billion industry in the world, and it's increasing at a cumulative growth rate of 5%
and more.
Yes, exactly. And if you look at the entire world, it's about 2.7 million robots in operation.
And we are still at the starting stage.
Exactly. So, and good news is that the highest robot densities near Sri Lanka, it's in Singapore.
Oh, wow.
World highest. But if you look at the quantity, it's not that big because it's a small country.
Correct.
But then the second.
But still a good point to start from.
Yes, exactly.
Where we can also learn from that country then.
Exactly, close by. And then comes China, then Korea, like that. And China is the highest actually buyer of robots in the entire world. 30 to 40% of robots manufactured in the world are actually going to China. So, so that tells you the story.
And that China is getting ready for the future.
Exactly, exactly. So, this is the world trend, nobody can deny it. So, in Sri Lanka also we have to get going with this technology if you want to survive as a strong, economically strong, developed country in the future. There is no other way.
And Professor, when we talk about this robotic process automation, or RPA, the software robots, what's that? A lot of people don't believe the fact that there's a robot inside their computer doing all the normal manual things like downloading an email, gathering data, but all that a robotic software can do now. Am I right?
Yes, true. This is a controversial definition, RPA, and some people call software robots. Even my friends who are in the field, they call software robots. I have argument always again with these words. I believe robot definition says that it needs to have some sort of mechanical presence or some sort of physical existence, right? If you look at just a simple AI entity, just a piece of software, I still have my reservations calling it a robot. So, you can have very fantastic autonomous agent doing file transfer, checking documents, entering in, data into a database. That normally people, you deploy people to do that. You can take them all out and then use a robotic tool. But I would say it is a advanced software tool, not just a robot is my definition. Maybe I am wrong, time will tell.
We respect your perspective there, Professor. Professor, let's talk about the cost factor, because decades ago, I think the big concern was, can we afford a robotic investment? Maybe for our factory, for production purposes, for whatever it may be, can we afford it? But today, I believe, many decades later, I believe the economies of scale factor is in the advantage of the investor. Am I correct?
Yes, correct. And on the other side, robots have become like advanced toys now. They are not very sophisticated equipment, they are advanced toys. If you look at comparing 80s and 90s and now into 2010 and this decade, there is a serious improvement in speed, accuracy, repeatability, and reprogrammability of robots. These are the 4 words that we use to define the KPI of robotic machines.
If I can request you to repeat that again, Professor?
Yeah, that is the accuracy and the speed, repeatability, and the reprogrammability. Repeatability means it should be able to do the same thing over and over again without a small error in the process. Reprogrammability is you can use the robot and program it for one application, say for example welding, and the next day you program it for painting, cutting, whatever.
So the application is flexible.
Exactly. You change the tool at the endpoint and use it for different application. So that is why we call it flexible automation in the first place.
It's very interesting, Professor, because just before the pandemic, when I visited one of the leading German auto manufacturers, I saw a lot of robots being kept aside, saying, no, we used it for one particular vehicle model. Now we don't make that model, so we don't need these robots anymore. But as what you're saying is nowadays you don't have to waste the investment. You can change the robot from one to another very easily.
Exactly. So why some of these auto manufacturers do not use these robots is the cost fact. Now they are very affordable. Why do you need this old machine? Now they use big manufacturers maybe 5-6 years, then they throw it away and they use it for second hand sales and all that. They bring in the new technology. So technology is changing very, very fast. While the capabilities increase in the robots, by the day the cost gets down. So that is the beauty of this business, and it's a very viable option now for industries to move from their traditional legacy technologies to smart, flexible automation like robots.
Professor, is it something still only limited to the big businesses, or is it affordable and applicable even to medium and small enterprises?
Well, that's the point. When I teach robotics, this is one of the first things I teach to my students also. You should not habitually go for new technologies, right? You have to be very
Don't go for it for the sake of it.
Exactly. You have to be very sensible. You have to connect with the reality, right? So if your business is like very small, when you start any business, initially you are very small, don't have to think about robotics or any smart technologies. I'm talking about the mainstream thing. So you use whatever affordable technologies to you and get going. When you see the demand increases and you have to deliver thousands and millions of units, right, then that is the time for you to think about smart technologies like robotics.
Professor, now sometimes they say a human has a very good ability for precision, but when it comes to robotics, most of the cost might actually be when you have to program the robot for that level of precision. For example, if I am making something by hand, I can judge and I can decide how it will fit in. Now, programming a robot to be able to do that is apparently quite an expensive affair. Where is the trade-off? Where do you decide precision and expenses for a human versus robot? Where do you draw the line and how do you balance it?
Well, robots are extremely precise. You can use robots to actually manipulate the world that you can't even see through the magnifying microscopic views. You can get this micron world 100 times, 1000 times magnified onto your screen, and then you can use a joystick to make movements, whatever centimeter, millimeter movements, and they are scaled down 1000 times, and you are operating cells, genes and all that. So that is the technology where it is right now. So therefore, when it comes to machines, not only robotics, the sensors, control systems, they are all developed to a very high level now. So there's no match there between human and machine when it comes to precision.
Machines have overtaken us. Interesting thoughts there. Professor, we are going to come to you with more information and more discussion points on that. Stay tuned. We will be back after this short break. This is Bisnomics. Welcome back to Bisnomics, your weekend's most profitable 60 minutes. Our focus is about the robotics in the world of business, the application, the implication, and most importantly, how to pragmatically make things work with regard to robotics for your business domain. And joining us for this discussion is Professor Rohan Munasinghe. Professor, now, when it comes to technology, most of the time we see people going all gung-ho about it. They are like, okay, this benefit is there, that benefit is there, this transformation is there. Some people think bringing in robotic systems is going to solve all their problems and make them the next star company also. They have some very candy coin dreams sometimes with regard to technology. In your experience, when businesses try to integrate robotics into their workplace, into their operations, what are the common challenges that they face?
Well, the state-of-the-art technologies, if you run your manufacturing plant, if you want to transform to robotics, is a big decision for the company. I think the first challenge is whether your people, the team, employees are ready for this transformation. Most of the time, historically, we have seen the records, the answer is no. People don't like this transformation from say legacy technologies to smart robotics. Therefore, I would say the companies who want to go through this transformation, they better establish a separate facility and recruit new staff or get their old staff who are willing to learn and deliver into that new thing, because transition in the same place, same machinery and taking different pieces and putting robotics most of the time doesn't work, because
What you're saying is you can't plaster your way through.
exactly,
It's a new approach.
Exactly. So this whole thing comes as a turnkey solution. It's not like cut and try most of the time. Well, cut and try methods are already happening in every industry. People are actually developing certain things, small gadgets, they plug it into various places in their manufacturing. That is happening all the time. Yes. There's nothing wrong with that.
But that won't give you exponential results.
Exactly. It's not the transformation, it's an organic or slow development. Yeah. So, second thing, the companies need to have a sense of social responsibility also, not just look at their economic returns. That's extremely important going forward. So, therefore, they need to take care of their employees also, right, because when you introduce a new technology, especially robotics, maybe you need to go for a layoff.
Redundancy program.
Exactly. Some people might lose their jobs and that will trigger a pressure wave in the society. And I think that should not happen. So
and already people are worried that robotics will replace them.
Exactly. So that is happening. But the thing is, if you look at over a period of 10-15 years, the net result is actually not losing jobs but creating jobs. The jobs that are created just because you are introducing robotics is not the same jobs that you were having some time back. So therefore, this will be, let's say my father is working in a certain factory and he loses job, I can have the job in the same company in a different facility.
In fact, Professor, a recent McKinsey report has shown that while these robotics and digital technologies might create a loss of about 85 million jobs, they create about another 100 million jobs.
That's right.
In various other fields. And I want to share this with you. There was recently a picture. They had a drone, and on this side they had a cameraman on a helicopter. And the caption of this post said, over the last 20 years, the helicopter pilot as well as the cameraman have both lost their jobs. But somebody commented below saying, hey, but think about it. The drone pilot and the drone manufacturers, everyone has got jobs.
Exactly. So this is the reality. So we should not hold on to the good old jobs all the time. So we have to embrace the development and the new opportunities coming up. So actually who is affected by this technology is actually the lowest layer in the blue collar in the industrial setup. So I think it's a good development, you know. So these people, actually there's always plus and minus in every development.
Are you saying we need to reskill them?
Well, yes and no. Yes and no. Some people will lose their jobs forever. We have to be realistic on these things. But there is always social responsibility thing in every company. They need to look at, and the governments also, they need to have some sort of lateral intervention to look after these people who are losing their jobs in the short run. But in the long run, it will be a net benefit to the society.
Professor, since we are on the topic of challenges of bringing in robotics into the workplace, do you think the mindset of the senior leadership of organizations is also a challenge? Because you can have all the new technologies and all the young managers or the young generation of that family business might be thinking of these technologies, but if the senior leaders, the senior leadership is not very pro-tech oriented, do you think this is being inhibited? Do you see that sometimes some of the senior leadership of organizations is not very willing to adopt this technology?
Well, Yeah, so I would agree with that statement because even though you are a CEO of a company, you are who you are. Okay, so there is always generation gap. The technologies change very fast, so therefore people cannot cope up with this development. So it all depends on the maturity and the visionary nature of the CEOs to look at the reality, look at the numbers, look at the graphs, where the world moves, the trends and all that. Then they can easily figure out this is the way forward and give the opportunity for the young minds to play, taking some risk and all that. So that leadership has to come from the top of the companies.
Understood.
Yes.
Professor, you have served our education system for quite a long time as a professor and as a senior lecturer as well in the university. Now, you are very close to the talent of this country. You see the talent of Sri Lanka. Tomorrow's talent, you are spending your valuable time, your knowledge with them. My question to you, do you see that the Sri Lankan talent is good enough to build world-class robotics? Are we ready as a country? Is the talent pipeline of this country ready to provide world-class robotic solutions to the world?
The answer is certainly yes. I have no doubt about it. The talent, skill, the motivation is there. But that alone is not enough.
Something's missing.
Yes, something is missing. That is the ecosystem. For anything to happen, any child to become a leader, there should be fostering environment. So unfortunately, I haven't seen in this country in my lifetime up to date an ecosystem being developed, because innovation actually cannot happen without major different pieces supporting the inventor who has the concept, the idea and the skills and all that. So to bring him through the path from start to the end.
From the concept to the product.
Exactly, until you get it into the market. So a lot of people end up their career halfway. So
they go to a few competitions, get a few awards, end of story.
That's it. Yes, they get the trophy, the certificate, some money also.
Yeah,
that's another story. And also the funding agencies in Sri Lanka, they only give funding, and they think funding is the only requirement here. No, it's not the case. Funding is just one piece of the whole thing. There are other 10, 20
like mentoring,
pieces.
proper guidance.
Exactly.
You need to incubate an innovation, isn't it, Professor?
Exactly. So, for example, all the universities in Sri Lanka now have business linkage cells. I am running the University of Moratu one, and we build these small ecosystems in universities. Nationally, we don't have anything, even though the science and technology ministries and different organizations in that ministry says that they have these things. I don't think there is a national innovation ecosystem. We are trying to do that for this country. It will take some time through the National Innovation Agency, the recent initiative. But we don't wait until that happens. We do it within our capacity at universities. So at Moratu, for example, we tested and built this innovation ecosystem where inventors can come in and they can disclose their invention, and we look at it, we do the technology evaluation and bring in mentoring support. We put the mentor into the group. The mentor will tell them what to do, how to do, and connect them to the different skill sets, then how to work with the legal systems, how to handle the human resource management problems, financial management. All these things have to come together for an idea to become a product during the value chain. So
you take them from tech expertise to business acumen.
Exactly, exactly. And in this process, we have lawyers, we have investors, we have industry people, we have the well-wishers. Everybody there has a role to play in this process. If you don't have all these pieces together, there's something missing in your ecosystem, and that will cause the process to stop prematurely. So this is what has been happening for most of the inventors in this country. If you look at the statistics, they say the success rate of an inventor to become an entrepreneur is about 5%.
Can robots replace the humans in the near future? Is that a question that you have? Let's see what Professor Rohan thinks about it on the other side of this short break. This is Bisnomics. Welcome back to Bisnomics, your weekend's most profitable 60 minutes. Our focus is about the robotics in the workplace. And joining me for this discussion is Professor Rohan Munasinghe from the University of Moratuwa. Professor, this big question that a lot of people have, probably influenced and inspired by a lot of movies they've seen in the past, but whether robots can replace humans in the workplace, and most importantly, as they learn and as they develop, what's going to stop them from turning against us? These are common questions that people have. If you ask me, even I don't have a clear answer to that. What are your thoughts on this?
Robots do exactly what they are supposed to do and what they are instructed to do and how they are instructed to perform. So, always there is this handle in the hands of the humans, the designers, the coders. It depends on how much autonomy you give to the machine, to the robot to perform. If you give the complete autonomy to not only to the robot, to any other machine, think about a vehicle, self-driving car. If you give the full autonomy, it might crash onto something, right? It has happened also in the US in the recent times. That's why they banned self-driving for some time. But in the future, it definitely will happen. When it comes to humanoid kind of robots, as you pointed out in movies and all, with guns and all, shooting here and there, right? Completely autonomous robots, right? They think themselves, they take decisions, they put their actions in, the decisions into actions. So, that is not impossible actually. That is not impossible.
Professor, I just want to share a case in point here with you. Facebook, they tried to create an AI engine for some of their business pages for communication purposes, and they realized that within their own system there was this AI robotic system that was communicating with each other in a language humans can't understand.
Well, that is a bit of a question. Today, robots are not able to generate their own intelligence. They have the intelligence designed by humans and then coded into them. So, that is why still we have some sort of control.
The handle is in our hand.
Yes, handle is in our hand. But in the future, we will lose this handle gradually. And also, you know, it depends on what technology, what advanced technology is controlled by these people, the scientists, the engineers and all. Like if you look at the history, great innovations, developments, the atomic bomb was built by Oppenheimer, right? So, it depends on how these people think. Let us say for example, a very smart coder, very smart guy in the world who can actually build AI systems, right, decided to do it like that, like in the movies, it will be a reality. Then at that moment, he loses his handle. I am sure everybody would want to do that and see how it goes. It's a very big risk taking. I am talking about the far-fetched future, but I don't exclude that from happening.
But we are fast approaching that.
Yes, exactly. So, it's very difficult to predict the future as we advance in this technology development in very unpredictable exponential manner.
And we could be looking at areas like robotic terrorism, etc., because some of the recent assassinations in countries like Iran, we saw they suspect that it's a robotic gun which is enabled with AI. You recognize the target and the machine activates automatically, and a drone is also overlooking the whole operation. Yes. Scary future, Professor.
Exactly, exactly. So, you have the ability to decide how much autonomy am I going to give to the machine. The moment you give it, you always can take it back, but whether you want to take it back or not can also be programmed. You can give it permanently.
Correct.
Maybe
with deep learning and automatic learning.
Exactly. Very smart bad guy would do that in the future. So, then we are all in trouble.
And we sometimes find that bad guys, just like in the movies, are quite smart even in real life.
Yes, there is always a bad guy.
Professor, let us talk about the future here. How intelligent can my robots be? For example, am I looking at a future where I'll walk into a hospital and there is a robotic engine there ready to do my surgery? Is that a possibility, or is it already happening?
It's already happening. Like for example, eye surgery and all the surgeries in the brain and all are assistive surgeries. It's not completely autonomous, not because it cannot be done, but because it is not socially accepted yet. Would you
As a patient, I would be a little worried in the
Exactly.
operating theatre if it's only me and the robot.
Yeah, neither do I. So I don't want a robot operating on me, right? I would take any risk and giving it to a human because I trust human. But this trust will also change the way we look at it. Our sons and daughters in the future, they will have the complete opposite mindset. They would believe machines more than the humans. Like for example, do you like to fly in a plane without a pilot?
Right now, no.
No. But do you know actually the pilots are not doing anything on the cockpit?
Yeah, so it's autopilot mode.
Exactly. Just the human presence there,
Correct.
just in case.
Just in
So
case.
that is how we think, how we perceive. But in the future, the perception will also change. So therefore, people will be willing to work with machines, just like working with human companions. Things will change in the future. Yes.
Professor, let's talk about some advice to young students. Now, there are lots of students with robotic inventions with them and they have innovative ideas. What is your advice to them? If they want their robotic solution startup to be a success, please share some wisdom with them on how to make it work.
Yes. So robotics is an application area. So which means if you do robotics, you need to know about electronics, computer science, mechanical engineering, and mathematics, among other things. So nobody has all these skills in one person, right? So therefore, you need to team up. Number one is team up. You figure out who is good in what, and look at your solution, the invention you are going to do in this area, robotics, and pick your colleagues and make the team. And also you need to look at what is the solution you are going to provide, what is the problem you are going to solve, and what is the benefit to the end user, whether it is a society or industry or whatever. And look at your competitors also, because others are also doing the same thing you are trying to do, and see what is your edge, whether this edge is sizable and sustainable. You have to look at that also. Number three is how to protect your invention, because you are going to put your time, your money, your energy, and other people's time, money, energy in this process. So therefore, you need to get some return on that effort, right? So how many years you can earn that revenue, and whether it is sustainable in the future. You need to have done your homework and calculation, sure for yourself, okay, this is going to work, right? That is number one thing. Number two, you need to have a good mentor to mentor you. So I'm talking about these young minds, right? You guys definitely need a mentor. The mentor will tell you, mentor is a senior person who has walked through that journey maybe 20-30 years before you, right, prior to you.
They walk the talk.
They walk the talk. So they know what it takes to bring the idea into a product and how to sell it in the market. With the mentor, you can increase your success rate by 30-40%, statistically proven, rather than going alone, right? So identify the problems and synthesizing the solution and protect the intellectual property, team up, and the mentor. These are the different pieces. So ecosystem I mentioned will have all these supports to the inventor. And then comes, so you have to work with the business world, right? You need to go through the legal system. Make sure you have some legal support. Make sure you have somebody who can drive your innovation into a product and service. Okay, just because you have a fantastic technology innovation, you can't have a business. It is a completely different mindset how to bring this product innovation into the market and sell it sustainably. So therefore, somebody who is not a very techie guy, but who is an entrepreneurial mind, you need to have in your team.
And do you find a problem that some of the young students, they have a brilliant idea, but communicating that to investors is a problem? Do you see that problem sometimes?
Yes, I do. I have seen this at Moratuwa University. The
Tech experts.
tech experts.
The best of the tech, the cream of the tech students.
Exactly, exactly. But they're missing that piece, entrepreneurial mindset. This is what we are working on at University of Moratuwa to offer them entrepreneurial experience, giving a new course for you to follow. But it's difficult. Entrepreneurship is actually
Difficult to teach.
should be in your genes, right? So therefore, why don't you bring in somebody who is really good in entrepreneurship and you do your innovation part, let the other guy to do the business. So I think that should be a best mix. While working with them, you will learn yourself, right? But it will be a very organic thing. So this is what we ask students to do. Yes.
Professor, on a final note, just to clarify with you, what do investors really look at when somebody goes with a business idea? Let's say a young student who is watching this show, who has an idea for a new AI solution or for a new robotic solution. He has a plan, he has an idea. He goes to an investor. He explains the tech side. Now, tech side wise, yeah, perfect solution. But investor might not be only looking at the technology. What are the criteria that investors are looking? What are the boxes that investors want to tick before putting their money?
Exactly. So the businesses are actually things that are happening already there, right? If they want to put a manufacturing plant from ground up, is a separate story. But you are referring to ongoing businesses, ongoing manufacturing processes. So the business people, they are looking at certain solutions that can be adapted. So therefore, the young guys who are actually very brilliant guys who have some ideas, they need to look at the existing, the state of the art, how the manufacturing is done, the factory flow, what are the machines involved, what are the steps involved, and then customize the invention so that it suits to the real world. So this adaptation is a missing piece. So therefore, there is a disconnect. The inventor thinks this is a fantastic idea, a product.
Yeah.
The business person thinks, no, you cannot adapt it to the system. So this is a very common thing. There's nothing to worry about it. So what we have to do as senior people, right, the mentors, we need to try to bridge these two worlds together, right?
The tech world and the business world.
Exactly. So this should be our duty and the government's duty as well. Yes.
The role of robotics in the workplace. This was our focus today in Bisnomics. I'm indeed thankful to our special guest today, Professor Rohan Munasinghe from the University of Moratuwa, for sharing his valuable insights and experience with us. Professor, it was an absolute pleasure to have you on the show. Thank you for laying it out for us, explaining the different facets, and for that valuable advice that you shared with our audience. I hope that some young entrepreneurs would have taken that to heart and will make the necessary changes in their business activities. And as you very correctly said, let's hope that those who are in the decision-making authorities and the seats, the right decision-making chairs, let's hope that they make the right decision and bring up the ecosystem for robotics in Sri Lanka. Thank you for joining us, and please continue the good work that you are doing for this nation.
Thank you, Tarindu. My pleasure, and thank you for having me.
And with that, we wrap up today's episode of Bisnomics. No matter what business you may be in, have a profitable week ahead.